Hey Rams, it's Miss Moreau. Today we're on page 53 and 54 in your notes. It is over fractions, decimals, and percents. Now, our standard here, the first part is going to be to generate equivalent forms of fractions, decimals, and percents. And it's also going to be part of real-world problems. But then we're also going to represent these ratios and percents with models, fractions, and decimals. So we're going to be representing them on models in just a minute. Okay, so you've already learned right down here about decimals and fractions, right? So to go from a fraction to a decimal, what do? Let's say I had like 3/8. What would I do to make that a decimal? Well, so to get from a fraction to a decimal right here, we're going to write divide. And what do I divide? Or what is my key word that we call this? Top dog. So we call it top dog goes in the house. And my example here will be just 3 divided by 8. That numerator is your top dog. Okay, 8 does not go into 3, but it goes into 30. 3 times 8 times 3 is 24. I subtract and get a 6. I'm going to add a 0 and bring it down. 8 goes into 67 times. 8 times 7 is 56. Subtract and get a 4. I'm going to keep on adding those zeros there. 8 times 5 is 40. So it's 0.375. Okay, and look, that's less than 1/2, right? That 0.3 is less than 0.5, and look, 3/8 is less than 1/2. So to go from a fraction to a decimal, so look at your arrow, the direction it's going, from fraction to decimal, you divide. Now, how do I go from a decimal to a fraction? Well, we just read it with place value. So I'm going to, write down, read with place value. Then simplify. So if I have like 0.36, that's my decimal, and I'm trying to get all the way around here to a fraction, I'm going to read it with place value. This is the 10th place and the 100th place, so it's going to be 36/100ths, and then I just simplify. I can divide both of these by 4, and I will get 9/25. Okay, that's fraction to decimal and decimal to fraction. Okay, now we have percents. So let's look at decimals to percents, okay, or percents to decimals. So if I had a percent, let's say I have 67%, okay, and I want to make it a decimal. Now, percent is just a number, a representation out of 100. It's just a comparison of something out of 100. So 67% means 67/100ths. So when I'm looking at my 67, your decimal is actually after the ones place. So you're going to move your decimal 2 places to the left. So it says move the decimal. So if you're going from percent to a decimal, I'm going to write 2 places to the left. Okay, we're going to move it. If I have a percent, I'm making a decimal, it would be 0.67. That's 67/100ths, and 67% means 67/100ths. Now, what does it really mean to move your decimal 2 places to the left? What am I really doing? I am dividing by 100. We are dividing by 100 when I move 2 places to the left. Now, if I have a decimal, let's say I have 0.45, and I'm trying to make it a percent. What's the opposite I'm going to do? Instead of dividing by 100, I'm going to be multiplying by 100, which will move my decimal 2 places to the right. So, move the decimal 2 places to the right. Okay, so to get from your decimal to the percent, follow your arrow up. We're moving it 2 places to the right, which would become, is that 0.45? We're going to move it 2 places over. 1, 2, that's a 45. That's a whole number now, and it is 45%. Okay, So what does it really mean when you're moving your decimal 2 places to the right? We are multiplying by 100. Alrighty, so that's adding percents in here. Now, you can go from a fraction to a percent, just like you can go from a fraction to a decimal, as long as your denominator is a factor of 100. Otherwise, just get it to a decimal first and then go to percents. All right, now over here are some sample problems, okay? Just a couple of quick sample problems to see that we know this, all right? So, if the shaded region of the model represents the part of the book that Katie has read, what fraction does she have left? All right, so let's see what she has read here. 1, 2, 3, 4 out of 5, 6, 7, 8, 9, 10. She has read 4/10 of the book. So what fraction does she have left? All of these that are not shaded, which would be 6/10. But let's also make that a decimal. How do I write 6/10 as a decimal? Well, that's 0.6. And how do I write this as a percent? What percent does she have left? Well, I'm going to take my different colored pen here, and I'm going to go 1, 2 places over, and that becomes 60%, because that would be 60 out of 100. Okay, next, what fraction, decimal, and percent of the model are shaded here? All right, this is a 10 by 10 grid, but you always want to make for sure, okay, because sometimes you'll see some that are not. So what is shaded here? 10, 11, 12, 13, 14 100ths. So what, you could simplify that. You could divide them both by 2, and you would get 7/50ths. Okay, your decimal would be 14 out of 100, 1400ths. So it's 0.14. And then your percent, remember your percent is just out of 100 anyway, so it is 14%. All right, look at this grid below. Which one is not true? Ooh, we have to see what's shaded in here. There are a lot of squares, but there are some partial columns here. So these are 10 by 10, so 10, 20, and here are 3 rows of 5. So 5, 10, 15 plus 20 is 35. So 35 squares are shaded. So we need to know which one's not true. Well, is this 35 out of 100 going to be 35%? Yes. Is it 7/20ths? I'm not sure. Is 3500ths shaded? 0.35 is 3500ths. Yes. Is 55% not shaded? Well, I don't know. Is 35 plus 55 100? Oh, no, that's only 90. Let's try this one right here. How can I figure that out? I don't see just 20 squares here, but I could simplify it. So 35 over 100, and I divide them both by 5, and I'm going to get 7 over 20. That is also true. 55 is not true. Okay, and last one. The square shown below is divided into equal sections. What percent of this square is shaded? Well, I have 1, 2, 3, 4 pieces that are shaded out of 1, 2, 3, 4, 5, 6, 7, 8 pieces total. 4/8, if I simplify that and divide them both by 4, I'm going to get 1/2. And 100% would mean the whole thing is shaded. So what percent would mean that half is shaded? That would be 50%. Alrighty, I have a little typo over here. But how do the models help you solve, not same, the problems? How do they help you solve the problems? Well, I think they're really good to give you a visual. They help you check for reasonableness. Like you could tell if a number is greater than 1/2 or less than 1/2. They're very good at helping, okay? Now, summary of your lesson. I want you to tell me how decimals and percents are alike. Okay, that's going to be your reflection question here. How are decimals and percents alike? Okay, Rams, this is due tomorrow, and we are using it in class. Make for sure that you're ready for this, okay? Have a great day.